Alright guys, so hopefully right now you've got your notes labeled 2.17 Graphs of Rational Functions Part 1. I'm aware that the last section in your notes you probably have is 2.13. So I had to skip one of them and just kind of move into this just for simplicity for you guys. So this is a really important type of function we talk about in Algebra 2. It's called a rational function. So the goal of this whole lesson that I've assigned through Google Classroom is for you to understand a general idea of what a rational function is and specifically what a vertical asymptote is, which is a feature of a rational function. Alright, so what we've got here is some definitions that I'd like for you to write. So we've got rational function here, and it says a rational function is a function defined by a fraction with polynomials in the numerator and the denominator. So that underlined part is really what I want you to write. So you've got this representation here on the side, and it says f of x equals p of x over q of x. So just kind of imagine p of x being a polynomial and g of x being a polynomial. So pause the video and write all that down because I'm going to keep moving. So just pause the video when you need to catch up. So another example of this, so let's come up with a polynomial. Well, let's say we come up with x plus 1. So we'll call that p of x. And then we come up with another polynomial that we'll call q of x. And we'll make it a quadratic, x squared plus 2. That's a rational function. So one thing, if we remember the definition of a polynomial function, is it does not have input values, x values, in the denominator. Well, now when we start making functions that have x or input values in the denominator, we have now created a rational function. Alright, so now, what the heck is a vertical asymptote? So, asymptote is how you say it. People always struggle saying it. There you go. So we're going to write this definition down, and then I'm going to show you a lot of different graphical representations of it. So a vertical, important to know that it's vertical asymptote, is that it's a line where x equals a number for a function. Okay, that means that this function f is undefined at that value. So that's really, that underlined part's really what I want you to write. So basically what we're going to learn is that when the denominator equals 0, you're going to have a vertical asymptote. So I'm going to really dive into what all that means. So the biggest thing I need everybody to have is this underlined portion of rational function definition and this underlined portion of the vertical asymptote definition. Alright, so if you look down here, we've got these two crazy looking graphs because we haven't seen functions that look like this yet. So basically the function is this curve here getting really close to certain values. And it's made up of two different curves there. So I really want you guys to be able to see that. So here you've got your y and your x axis. And then this dotted line right here is an asymptote. So it's that vertical line, vertical asymptote, where this function has a value that doesn't work. It's undefined. And we're going to really dive into what that means. And here's a separate representation of a rational function. So we're going to see how rational functions are made up of various curves. We've got two curves here, and then here is that dotted line. Basically, you can think about this asymptote or this line as a value that this curve's going to get really close to, but never actually touch. So it's going to happen on both sides of this function here. So give yourself a visual, one or both of these graphs, just so you kind of start to understand what an asymptote looks like. Now when we graph these on Desmos or on our calculator, those dotted lines won't show up, but we will be able to sort of visualize and figure out what those values are. Alright, so here's another picture that you can add to your notes. So here's our rational function. Alright, and just kind of looking at this right here, so we've got our asymptote right there, which is at the x value 1. So basically what's happening is this function is not defined at 1. So that dotted line is a barrier saying, oh, function doesn't exist here, but we've got all this space of the graph and all this space of the graph where it does exist. On this graph over here, we can't really see a dotted line. So that's interesting. Our function is 6 over x. Well, our asymptote is actually overlapping the y-axis because this function is not defined at x equals 0. So really my goal on this slide is for y'all to kind of listen and see some visual representation of rational functions and vertical asymptotes. We're going to now go into some stuff you'll really want to write down. Alright, so parent rational function. What does parent mean? Parent means the most simplest version of all rational functions. Like, what is the most basic version of this function? Well, it is f of x equals 1 over x, right there. So my question to you is, where is this function undefined? Well, I think to answer this question, we need to pause and kind of backtrack and talk about undefined. So, undefined fractions. 1 divided by 0. Type that in your calculator. Guess what it's going to tell you? Undefined. Because this doesn't represent any possible value. Negative 5 over 0. You guessed it. Undefined. 1,000 over 0. Undefined. So what's the trend here? Any number divided by the value 0 will always equal undefined. So make a note for yourself about that because that's really important. Students get that flipped around. So backtracking again, what does an undefined slope look like? It is a perfectly vertical line, so you maybe can start to guess why I'm bringing this up. Vertical lines, right? So if I was to graph this line on my coordinate plane, it is an undefined slope. And the equation for that line is x equals 3. Why? Because any ordered pair on this line, no matter what it is, I go to write that xy value. Guess what every x value on this line is? 3. So it's just showing you a vertical line where x equals 3 with an undefined slope. So all of this undefined notation you want to make some notes of in your notes because I don't want it to be confusing with what we do later. Another quick note is zero slope. Well, when do our values in our zero fractions, like we wrote undefined fractions on the last one, well, what about zero fractions? Well, let's see what the difference there. If we have 0 over 3, 0 over 1,000, 0 over negative 5. Guess what all of these values simplify to? 0. So hopefully you're seeing the difference here is that if we have 0 on top of a fraction over any number, we're going to get 0. This will play in later, so I do want y'all to have this, just a quick note in your notes about the difference in undefined and 0. It's often mistaken in math, so I want to clear that up for y'all. So if we have a 0 slope, that's going to look like a horizontal line. Alright, so if I drew this line, that is a horizontal line with a 0 slope where we would write our equation y equals 3 because any point on this line, if we write that ordered pair, our y value every time is going to be the same. It's going to be y equals 3. So we've got y equals 3, it's a 0 slope, and we've got a horizontal line. All this information is going to be really helpful later. So get that noted in your notes. All right, so let's go back to this. Parent rational function, f of x equals 1 over x. Where is it undefined? So now we talked about undefined. How do we figure out undefined values? Our denominator is 0. That creates an undefined value. So what would create this whole expression to turn to an undefined value? If I plugged in 0 in the bottom. So x being 0 is a problem because when I plug it in into my function, I get 1 over 0. So that means that the value f of 0, it's undefined. We can't have that. Doesn't work. Function doesn't allow it. So the line x equals 0 is our vertical asymptote. So I'm going to abbreviate here, VA, for vertical asymptote. And we're going to write x equals 0. So the vertical means up and down, asymptote actually overlaps this y-axis here. And something I'm going to give you, because it's not my goal for you to learn this yet, is the horizontal asymptote. We will work on this later. This will be the second part of this section, and that is y equals 0. Well, we just talked about a horizontal line going this way. So basically, when we're graphing this rational function, we've got these two imaginary asymptotes, one vertical, one horizontal, where the function does not exist. And then we're going to graph these curves right here. And this is just a rough sketch. I'm just trying to get you guys familiar with what these functions are going to look like. All right, so we've got our asymptotes drawn. We've got this really basic rational function going on. What is our domain range? Well, if we remember, domain is all possible x values or inputs, and our range is all possible y values or inputs. All right, so domain, where do these x values exist? So I've got an output for every x value on the negative side. So I would do negative infinity all the way up to this x value 0, where I'm starting to have a problem here, right? So I'm going to go to 0, but I'm not going to include it. And then there's this u here that pops up. Don't worry too much about this notation if you're stressing about it, but I do want it in your notes. We're going to work on domain and range a lot more later, so you're good to go. So what do I have right here? This is not an ordered pair. This is a representation of this section of input values. From negative infinity all the way up to 0, I have this function happening, right? So we're saying, hey, your function can happen in between these values. And then it's like open parentheses because 0 is not included. Because something weird happens at 0. We've got this asymptote. So we skip 0, and then we say, hey, our function happens all the way from 0 to infinity. So then we'll put 0 to infinity. So that's how we're going to write our domain. Like I said, we're going to work on this a lot more later. All right, so now, let's see here, purple. Our y values. So we've got negative infinity down here, positive infinity up here. So kind of same thing. Our function it's got all this going on in the negative y-axis, right? Because we've got something right here. So we've got negative infinity to 0 again, but then something weird happens at 0. We jump over it because we've got this horizontal asymptote, and then we've got this function all on the positive side. So from negative infinity to 0, and then we've got this u, which means and 0 to infinity. So this notation right here is just saying, hey, I skipped over 0. So all these real numbers are happening, but when I get to 0, I got to jump over it. So that's what that means. So make sure you got all that good stuff written down. Okie dokes. You might want to pause the video. All right, so example 1, we're just kind of going to roll right into another example. Example 1 is going to be this function that I would like all of us to write. It is g of x equals 1 over x plus 4. So let's go back to our central question. What is the point of all these videos? So I'm adding in additional information because I want you to get used to hearing it, but the whole point of this lesson is to figure out what is a rational function, get comfortable with that, and what is the vertical asymptote. So here you're going to see that I already provided the horizontal asymptote. We will do that later. I'm just providing it so that you can kind of get used to graphing these. I'll teach you how to find them later. All right, so vertical asymptote is what value, so an x value, that makes the function undefined. What is an undefined number? something divided by 0. We can't have it. Doesn't make sense. So we're asking ourselves, what can I throw into this bottom of the fraction that's going to generate an undefined value? Well, let's say I did 1 over 0 plus 4. Well, what's 1 over 0? Undefined. Plus 4, still undefined. Doesn't make sense. So by kind of thinking that through and really focusing on that denominator, I realize that my undefined value here is 0. So my vertical asymptote is x equals 0. Alright, so here we go. We're going to kind of put these asymptotes as dotted lines on our graph, and I just ask you give yourself a rough sketch of this. So we're going to do a dotted line at x equals 0. So remember, it's a vertical asymptote at x equals 0. So if I'm thinking about my x-axis at 0, we've got this dotted line. It just so happens to overlap the y-axis. That's okay. This is your vertical asymptote where x equals 0. All right. And then, because I provided it for you, I haven't taught you how to find it yet, this horizontal asymptote at y equals 4. So 1, 2, 3, 4. So I'm going to make it a dotted line also. Boop. All right. So obviously I've got some curves that happen around these two asymptotes. We could start plugging in values. We could graph on our Desmos or our calculator if we had one and kind of see where these curves happen. So I'm going to just kind of guide you through this. I'm going to tell you that the curve, move this up, is in these two corners. You'll learn more about how to do this. I will tell you, because these graphs are kind of funky, we're going to be using a lot of Desmos later for graphing, so it'll make everything easier and more visual for yourself. So here is the entire graph. This is all of the graph for g of x. Okay, so I don't want you thinking that these are two different graphs. No, these are the same. All right, so make sure you've got that all marked in your notes. All right.